In 1977, NASA launched the spacecraft Voyager 1 and Voyager 2. Their mission was to explore the outer planets of our solar system. But no one imagined that nearly 50 years later, they would still be active and crossing into regions no spacecraft has ever reached. And when they did, they found something completely unexpected. At the very edge of the solar system, Voyager detected a zone so intense, so extreme, that NASA researchers were stunned. A mysterious region where plasma heats up to over 50,000 degrees. Not a myth, not science fiction, but real data from humanity's farthest space probes. They call it the Wall of Fire. In 2012, Voyager 1 became the first human-made object to cross the Heliopause. Voyager 2 followed in 2018. What both probes recorded astonished scientists. At the threshold, instruments detected a sudden spike in plasma temperature, soaring between 30,000 and 50,000 Kelvin, or up to 90,000 degrees Fahrenheit. It was unlike anything seen before. This wasn't a solid wall, but a zone of extreme energy, a transition layer where solar wind crashes into interstellar space, compressing and heating the plasma to astonishing levels. NASA scientists nicknamed it the Wall of Fire, not because it burns, but because of its searing temperature and energy density. 50,000 degrees, but Voyager didn't burn. So did Voyager get scorched? Actually, no. Despite the extreme heat, the plasma in this region is incredibly low, just a few particles per cubic centimeter. In real-world terms, there's not enough material to physically transfer heat in the way we experience it. Think of it like this. You're inside an oven, heated to 50,000 degrees, but the oven is nearly empty. Almost no molecules are there to touch your skin or transfer heat. That's what Voyager experienced. It passed through this blazing frontier, cool and undamaged, recording the very first data from beyond our solar bubble. Voyager's discovery showed that the edge of the solar system isn't a static boundary. It's dynamic, constantly shifting, pulsing with the sun's activity. The entire region, called the heliosphere, acts like a protective bubble, shielding Earth and the inner planets from harmful galactic cosmic rays. And just like a ship plowing through water, the sun's movement through the galaxy creates a bow wave, a turbulent, compressed region of heat and magnetism. That wall of fire is part of that bow wave, a visible trace of the sun's influence fading into the background noise of interstellar space. One of the most surprising findings, Voyager 1 crossed the Heliopause at around 121 astronomical units from the Sun. Voyager 2 crossed at 119 astronomical units. That 2 astronomical units difference showed that the heliosphere isn't perfectly round. It stretches and contracts depending on solar activity, kind of like a beating heart. Another surprise, scientists expected the magnetic field to flip dramatically beyond the Heliopause, but it didn't. Instead of a sharp break, the magnetic field gradually blended, hinting at a more complex and layered structure between the solar and galactic magnetic fields. The takeaway? Space isn't made up of clean, separate zones. It's fluid. It's layered. It's alive with energy. This region matters more than we think. The heliosphere blocks most, but not all, cosmic radiation. During times when the sun is less active, more cosmic rays sneak through and can reach Earth. These variations affect everything from astronaut safety to satellite health. Voyager's readings helped scientists predict radiation conditions, which is essential for planning deep space missions, including future trips to Mars and beyond. Thanks to Voyager, we now understand that the boundary protecting us is more complex and more vital than anyone realized. Voyager's crossing wasn't just a scientific milestone, it was a human one. For the first time, a machine built by humans physically left the sun's protective influence and entered interstellar space. Each Voyager probe continues to send faint signals from billions of miles away, even as their power supplies slowly fade. To conserve energy, NASA has been turning off onboard instruments one by one. By the early 2030s, both probes will likely fall silent, but their legacy will never fade. Each carries a golden record, a time capsule of sounds, greetings, and images from Earth, meant for any future civilization that might find them. What comes next? NASA is already planning the Interstellar Probe, a future spacecraft designed to go 3 times farther than Voyager and map the heliosphere in full detail. It might help answer the big question, does every star have a wall like ours? is this fiery boundary, a universal feature of star systems across the galaxy. Voyager showed us that the edge of the solar system isn't cold, silent, or empty. It's a roiling frontier, alive with heat, energy, and motion. If you found this discovery mind-blowing, hit that like button, subscribe for more cosmic stories, and share this video with someone who loves space as much as you do. From Earth to interstellar space, we're just getting started.